Today we're going to be discussing more about for loops. So as you recalled last week, we introduced this for loop structure where it allowed us to look at each character of a string individually and act on it. That's not right. So in particular, we were using for loops to accumulate over values. So I could say something like, let's create an accumulator variable called answer. We'll set it to empty. And let's then iterate over the string A, B, C, D, E, F, and just accumulate that answer as we go. So I can go into Python here. I can say I have some answer that's empty for x in A, B, C, D, E, F. I can say answer is equal to answer plus x. And then we can just print answer. And you can see that we're just accumulating an answer as we move. Because we do this type of accumulation so often, there's actually a short form for writing this. And it looks like this. Some of you already may be familiar with this syntax. So when I write answer plus equal x, that's equivalent to writing answer is equal to answer plus x. I didn't want to show you this last week because I didn't want to overwhelm you with new stuff, but you don't have to use it. This piece of code and this piece of code are equivalent, so it doesn't make a difference to me which one you use. But you should know how to read this, right? This type of stuff is going to show up on your exam. There is, in fact, a bunch of these type of short equivalents, or shortcuts. So you can say x plus equal y, and that's equivalent to x is equal to x plus y. I can say x times equal y, and that's equal to x is equal to x times y. You also have the same thing for division and modulus. So let's keep that in mind while you're programming, that you have these short forms available to you, which may clean up your code, but in the very least you need to know them so you can trace code that we give you on your midterms and finals. Okay, so let's use this new shortcut and just write a simple program that removes spaces from a string. So let me get out of here. Desktop, it's Tuesday, touch Tuesday. You can see everything okay up there? Just let me know if anything goes off the edge. Okay, so I need to define something called remove spaces. I'm going to take a list of characters, which is a string. I'm going to return a string. Removes all spaces from C's. So remove spaces maybe from this. Right, that should be that. And remove spaces from one space should return empty. And remove spaces from something with no spaces should just return the same thing. All right, so this type of programming question is going to be very typical for us. So it's going to create an accumulator variable, call it answer, which I'm eventually going to return. And all I have to do is walk through the string. So for C and C's, take my answer and append to it. If C is not a space, then I append to answer C. All right, and let's just give this a print, just so we can see what's happening. Okay, so I'm going to read this into my Python interpreter. Whoops. So now I have this remove spaces. Let's give our test examples a try. Perfect. So as you see, the Python was walking through each character. And then it's accumulating the characters provided they're not spaces, right? So this seems to be working. Remove spaces from empty gives me none. Remove spaces from no spaces should just return back. There we go. Okay, so how can we code refactor this a bit? Well, this is perfectly fine already, but if you wanted, you could write something like this. Answer gets plus equals C if C is not equal to a space, else you append nothing, right? It's really up to debate which one of those two is actually more simple, but either one is technically correct. So you choose whichever one you want. Okay. So I'm just going to throw this in a giant file and throw it up on the website for you guys later. So there's other types of variables we use in loops that are quite typical. So last week we looked at accumulating a value. Now I want to count something, which is like accumulation, except you're accumulating plus ones, I suppose. So when we want to count something, we often use a counting variable in order to do so. So let's write a function now that counts spaces from a string. So count spaces, right? All right, so I'm going to count spaces from C's. Maybe count spaces in no spaces is 0. Oh, that's not a string. This should be an integer. Count spaces in here. Maybe that's 1. Count spaces in here. That should be 3. Okay. So again, I'm going to start with an accumulator. Yes. How about now? So you notice that I always sort of write my answer is this and return answer as soon as I write a function. That's a useful strategy, I find, right? You're like, okay, I'm going to build the solution and it's going to go in here and I'm eventually going to give it back. So the problem with these accumulators or these counters is you always need to find some type of like base example, like where to begin. Right? So when I was accumulating a word, it was sensible to begin at the empty string. When I'm accumulating a count, what should I start at?
0.
Thank you. So then I have to walk through this, right? I look at every character in my string. I say if C is a space, shoot, that's not what I want. If C is a space, then I want to say something like, okay, I'll make this even more explicit. Count. Right? If C is a space, then count plus equal 1, right? Which is the same thing as saying count is equal to count plus 1. Right? So I can read this into my Python sheet. I can count the spaces in here. I can count the spaces in hello world is nice, 3. And I can count the spaces in the empty string, and that should be 0. Perfect. I could do another code refactoring here, but I'm just going to leave it like this because it's perfect this way. Also going to throw that in the file online for you. Okay, so we have accumulating variables, we have counting variables. One last type of variable, which I call a candidate variable or a current something variable. We'll often want to walk through a group and find the largest member of that group or the smallest member of that group. And how we're going to do that is we're going to say, okay, this is the first element. Is the second element bigger? If the second element is bigger, then that's the current largest. And look at the third element. Is the third element bigger than our current largest? No. Okay, then our current largest remains our current largest. And we're going to repeat this procedure throughout the whole string. So let's write a function that returns the largest character from a string, largest by Unicode. All right, so definition, largest character from C's, which is a string, and we're going to return string. So this returns the largest character by Unicode. And let's see here, largest character, character in exclamation mark, asterisk, A, and A. That should be A. Largest character in hello world. I think that should be R. Okay. So this is going to be my current largest. I want to do something like this. Guys, can I help you out? Is there a problem? No? Okay. Current largest. I'm going to do something like this, right? For C in C's, the current, if C is bigger than the current largest, right, then current largest should get C, right? And then I'm going to return the current largest. So the question is, what should the initial value be? Who said that? Okay, so this is one of the suggestions, but what's wrong with this? Well, what happens if C's is empty? Right? You made an assumption that I'm passing you at least one character, which is an okay assumption. So I'm going to add that in. Right? I'm going to add assumes C's is non-empty. But you got to start thinking about coding this way, as if I'm going to give your code to some adversary who's going to try to break it, right? Because your assignments, like, you're going to have to get used to trying to break your own code, right? Just because your assignment passes the test cases in the doc string online doesn't mean we're not going to give you more edge cases, right? So you have to ask yourself, how is this code going to break, and does my code do something appropriate in that instance, right? So just be aware of that. Okay, so we're going to leave this code assuming that the input string is non-empty, so I can have a first candidate. Later on in the lecture, I'm going to show you how to resolve that problem. Okay, so this should work. So let's give this a try. So we have largest character of hello world. Perfect. Largest character of this. I think this should be A. Perfect. Okay? We just use loops in 3 different ways, right? To accumulate a string that we're building, to count something, and then to find the largest version of something. I have to mention one thing. We just wrote a built-in command over again, right? It is already the case that maximum will work on these things. But just because something's a built-in command doesn't mean we're not going to ask you how to write it. So don't get too used to the built-in commands, because we can easily say on your exam, max is a built-in command in Python. Implement max, right? Without using max, right? So you should, it would be a good practice to try and implement the built-in commands, some of the simpler ones. So note, we would never really write something like this, because max, you have to assume the code that other people write is better than the code that you would write. Right? I bet you the person who coded max in Python, like, made the world's best maximum function. Right? We should look at it one of these days. I'm curious how they did it. Okay, so I want to combine some of these ideas that we've sort of introduced today. So I want to write a function that removes all of the largest characters from a string. So can anyone describe in English the 2-step process that we're going to have to undergo in order to satisfy the output conditions for this function? Well, in order to remove the largest character from a string, what's the first thing I'm going to have to do? First, I have to find the largest character of the string. Okay, but we're going to be lazy programmers, right? That is to say, good programmers. So, remove largest characters from C's, which is a string, and return a string. What this is going to do is remove the largest character from C's. Largest character, so something like hello world, in smaller case, should remove what? Oh, let me do hello world. Right, so this way it will return hello world. If I remove the largest character from AAA, what should that be? Empty string. Not space, not this, empty string, right? The length of space is 1, the length of empty string is 0, right? They're not the same thing, right? Okay, so I want to accumulate some answer here, and that gentleman up there said the first thing we had to do is find the largest character, but that's easy, because I have a function which does that already, and I'm not going to write it again because I'm lazy. Okay, so we have the largest character. Why did I put a 0 there? Because I want to accumulate something. So I'm going to make it an empty string. And now let's go accumulate. For C in C's, if C is this largest character, then skip it. Oh, wait, you don't know what a continue is. If C is not the largest character, then I'm going to accumulate on this value. Answer plus equals C. And then I'm going to return C. So let's see what we got here. Remove largest character. from Wello world. That doesn't look right. Oh, thank you. Thank you. Okay. There we go. That's much better. Okay. So we learned some important lessons, right? Once you write a largest character routine, you really shouldn't rewrite the contents of this in your function. You should be reusing your functions, right? Plus, the way that we name our functions really verbosely makes it so that we can read this code quite easily, right? So the largest character gets the largest character from C's, right? It almost reads like an English statement. Okay, so I never talked about this because it may be confusing, but it's very useful when programming to know it. So let's think about what would happen if we try to cast one character as a Boolean. All right, what do you think this would give us? Well, it's one or two answers, yeah. Or, okay, so you say true. Do you have any reasoning behind that?
Because it can't really mathematically decide on strings, and it knows that empty anything is false.
Okay, that's the correct answer. Okay, so in Python, groups like strings, collections of things, can be in two states, empty or not empty, right? So anything that's not empty will be classified as true by the Boolean casting. Anything that's empty is classified as false. Doesn't really make much mathematical sense, but it makes a lot of programming sense, right? You'll be able to say something like in your program. So here when I had my, where's the largest, current largest. Here I could say something like, if not C's, string is empty. Right. This is how I can test for an empty list, right? And it's a nice way of doing that. But so hello is a non-empty group, so its Boolean value should be true. This is an empty string, so its Boolean value should be false. Okay, and again, I want to emphasize that the space is different than the empty string, right? The space is not an empty group. It's a group that's comprised of a space. This is something interesting and very useful. Okay, so we can string compare, right? So empty string is less than A. That's true. Okay. Furthermore, empty string is less than the character who has Unicode 0. Okay? So what does this mean? Right? There is no character, Unicode character -1. So this means this means that the empty string is smaller than every single other character, which means that I can replace this with the empty string. Right? The very first comparison is going to win. Right? What's larger, the empty string or my first element? Well, your first element, provided it's not the empty string. So I can actually change my current largest and do this. Okay, so this is actually a lot more, this would be a lot more easy to describe if I was allowed to use integers. Right? So imagine trying to find the smallest integer in a list. And remember, we want a comparison variable. In that number example, what should you set your initial candidate to if you're looking for the smallest member of a list? Float infinity. You set it to the largest number, right? Because no matter what, your first comparison is going to pick the first thing in the list. If the list is not empty, and you're trying to find the smallest number in the list, if you compare any number with float infinity will be larger, right? So that's the analog to this, right? My first candidate is the smallest possible thing, which guarantees that if the list that you give me is not empty, that the first thing in that list will be set to the new candidate. So go to the labs and give this a try. Whenever you want to start finding the smallest or largest version of something in a group, you should set your candidate to the smallest or largest possible thing that the group can be. right? So like negative infinity, float infinity, or, right? I guess I'm just trying to say the empty string is like the negative infinity of characters. Yeah.
What is about the biggest string, like if you want to find like the smallest character, would we just set up like
Yeah, in that case, so the question was, if I wanted to write a new function which found the smallest character, what then would be the accumulating value that I would set to default? Yeah, I don't know. That's a good question. Yeah.
You just set it to the first character, and then that way you.
Yeah, but then we have to check that it's not empty, right?
Right, but you if it's not empty.
Yeah. Okay. Yeah. Sir, I could put an if statement in that, but like the question is, if I wanted to do it without first checking if it was empty, right? That's the purpose of choosing these smart accumulators. It lets you avoid one if statement. But I guess in that case, you would just use an if statement, right? I don't know what the largest. I don't know what the float. I don't know if like negative empty is anything. Yeah. I don't. So. Yeah.
Could you just set like an arbitrary large character?
Yeah, but then you're putting an edge case. Well, if I gave you only the string of the largest character, then you would return false. Or you'd return empty. You produced an edge case. So that would be the other idea. Find the largest Unicode character and set it to that. But then that creates problems as well. Anyway, so I don't have an answer for you in that direction. I only have the string direction. Okay, so I have about 20 minutes. So I want to show you two things, right? And these two things I'm going to show you are going to themselves be broken into two parts, right? And there's going to be like a math part, and there's going to be a computer science part. You don't need to understand the math part, right? The math part is not going to be tested, but the computer science part will be tested, right? So if you don't understand this slide, it's fine. We're not going to test you on it. So for those of you who are going to be doing more mathematics, you may have already seen, or you will soon be shown, two symbols, the for all symbol and the exists symbol. So in mathematics, the symbol upside down A, I always loved learning new notation when I was in school. It made me feel super smart. So this was one of my favorites. So the upside down A is a symbol that reads for all, and is used to denote that every member of a set satisfies some condition. So a statement like this would read, for every x in x, px, right? That means px is true, right? We're checking some predicate. In the case where x is enumerable, right? Like in the case where x is a string, and by enumerable I mean the set elements are ordered and numbered, right? I know what the first one is in a second. This condition means that it is true that p of x naught is true, and p of x1 is true, and p of x2 is true. This creates this sort of like infinite chain of conjunctions, of ands. I can write a Boolean statement like this. Oh, I don't know what happened there. K double prime. This reads, for every x in x, x is less than the character k, right? And that statement is going to be true for this x, right? Because each of these characters are individually less than k, but false for this x, because although j is less than k, k is not less than k. And every character has to satisfy the condition for everything to be true. So let's write a function that checks this condition. All right, so I'm going to write a function foo. It's going to take in some characters, or string. It's going to return a bool. And this is going to check condition 1 on slide 11. Yeah, slide 11. So it should be something like foo ABC is true, and foo, gee, I must be hungry. Where did I start? J. KLM should return false, right? Okay, how can I write the code for this? So, I want to check some condition. If I write a lambda statement, are you guys going to freak out and tell on me? Okay, I'll write it like this. So we can write a function within a function. They're called helpers. So I want to have p, which takes x, and I want px to return x is greater than k, right? Or was it less than? Less than. Okay, so now I want to walk through my string. For c in c's, I want to check that it is true that this is true. Okay? So I'm trying to make sure that every single character in this string returns true and passed by P. So when should I exit this function? Right, so here I can do a truth test on P. Right, so if PC, if the predicate at this character is true, then what do I do? Do I stop? Do I return false? Do I continue? Continue. So I don't want to show you what a continue is. So I'm going to say if not PC, right? Or maybe I can say, make it more explicit and say if this is false, right? Although it is better to say this, right? If it is not the case that the character I'm looking at satisfies the condition P, that means this statement is false, right? I found something which doesn't evaluate to true, so I can return false immediately, right? If I make it through this loop, then I return true. I fail to find any character which forces P to be false. Okay, so if I go through here, and I'm just going to check, here I'll just print so we can see. Let's print C, and then what P of C evaluates to. So let me just exit here, go away. And I have this foo, and let's look at it at A, B, C. Okay, so Python was walking through this string, and it said, okay, the first thing I need to look at is A. Is A less than K? True. Okay, so continue. Let's look at B. Is B less than K? Yeah, that's true, so continue. Let's look at C. Is C less than K? Yeah, that's true. Oh, I've exhausted the string. I'd never found a false, so I should return true. Okay, let's look at the other one, right? JKLM. Okay, I looked at the character J. It is less than K, so that's true. So I should go to the next character, which is K. K is not strictly less than K, so that's false. I found a false, so return. I'm done. Right? You can't satisfy the condition for this. So small spin on this. So there's the upside down A, and now I'm going to show you the backwards E. So in the backwards E in mathematics denotes there exists, right? And is used to denote that there is at least one member of a set that satisfies a condition. So a statement like this reads, there is some x in x satisfying px. Or the exact reading of this is, there exists x in x such that px. Right? I love writing math like this because it's like there's no room for confusion as to what's being written and communicated. So again, in the case where x is enumerable, that is the elements of x are ordered and numbered. This condition means it is the case that px0 or px1 or px2 or px3. That means we're just searching for any element xi which satisfies p. That satisfies p. So now if I have a statement, it's the same statement from 2 slides ago, except I swapped out the for all with there exists. Now this says there is x in x such that x is less than k. And now it is true for this x because a is less than k. And it is true now for this x because even though it is not the case that for every character in JKLM is less than k, it is the case that at least one of those characters is less than k, that there exists a character less than k. So let's code this up, right? So it's going to be very similar. And I can, calling this bar. Okay, same P. That's going to erase this. So I want to do my condition. So I'm checking. I'm going to walk through my string. And I'm going to check the condition P. And what am I going to do with it? So when can I escape bar? Right, I'm looking to check if a single character in C's satisfies P. Return 1. Yes. So if PC is true, then I can immediately return true, right? Because I found a character that satisfies the condition. If I iterate through this whole thing and don't find a single C which satisfies that condition, then here I can say false. It's basically, I'm saying, look, I've looked at every character and not a single one satisfies them. So I need to change this. So let's read this in. Okay. So I read this in. I have bar of ABC. Perfect. I have bar of JKLM. Perfect. I'm just going to give a print here. So print C and P of C. Could someone give me a string which would fail? You have to give me a string where no character in the string is greater than K or is less than K. Huh? Are you trying to trigger me? When you're playing video games and someone types that at you, you're not having a good day. Why did this do it 3 times? Ah, yes, sorry. Okay, so this did it 3 times because, okay, we'll start like this. So Python walked into ABC, it looked at A, it said A is less than K, so I'm done. I found one, right? For this one, Python said, okay, the first character is Z, that's not greater than K, try the next one. That's not less than K, try the next one. Oh, that's also a Z, that's not greater than K. Less than K, try the next one. The next one is Z, that's not less than K. Try the next one. Oh, there is no next one. Okay, you're done. False. I couldn't find anything. Okay, so we have those 2 functions. And I still have some time to show you the last thing that I think is cool. Okay. So thus concludes the stuff that's testable. Now I'm going to show you a little bit more advanced stuff in the last 10 minutes. Right? So it is possible to pass a function, right? And it was not very smart to write this foo and bar, right? What I'd rather do is write a there exists function and a for all function, which accepts a character string and a condition, right? P and the string at the same time. So I want to do that now. I want to implement functions for all and there exists, which take in a string and a function. Right? And then I want to use that to check this condition, right? Which reads, for every x in x, there is a y in y, such that x is greater than y. Right? And I'm going to do this in such a way that we're just basically implementing the mathematics like directly. Okay, so it's a little bit higher order, but let's do this. Okay, so def for all. And we have x, which is a string. And I'm going to take p. So there's a problem here, because I want to write this. Right? But there is no function type. Okay, so I have to show you one thing. Let me see here. Code. I need to call in. Where is it? This. Okay. So I haven't shown you how to use libraries yet, but libraries exist and you can ask them for stuff. That's about as much as I'll tell you about libraries at the moment. So I can actually get this function type so I can have this in the header. Right? And then what is this going to return? This is going to return a bool, and it's going to return some bool. Okay, so I also want a there exists, which does the same thing. And it's going to return something. Okay, so this is going to check for all x in x, px. Okay. I don't really want to write a doc string, but whatever. Okay, so def takes x and return x less than k. And I want to be able to do something like for all ABC. Whoops, I didn't do that right. P. This should be true. And this should be false. Okay, so how do I do this? It's very similar. So for x in x, if not px, then return false, else return true. Right? So I can go into here now, and I can say, okay, I really just need lambda functions. Lambda x takes x to this. Right, so this is something like P of A should be true, and P of L, P of J, K, M should be false. So I could do something like for all A, B, C, it is the case that P, true. For all A, B, C, J, K, L, it is the case that P, false. Okay. You can do the same thing down here to there exists. Very similar. For X and X, if PX, return true, else return false, right? I'm not going to write the doc string. So if I have P, some lambda function, yep.
You have to specify function type in the contract. It can't be a bool because we return a bool.
No, P is not a bool. It's not the return type, right?
It's just a function.
Well, if I gave you true, it would really screw up your code, right? Like the function type isn't bool type, right? If you're saying this can accept a bool and I pass you true, that's not going to work. You can't evaluate true can't accept values. It really has to be a function type. It's a function type which itself has a signature, right? And you could put that in, but that's a little bit advanced. Okay, so how much time do I got? Okay, I have 4 minutes, so just give me. This is cool because I'm almost done. Okay, so I have that P. Now I want to check there exists ABC true. So there exists one in this one, ZZZ, false. Okay, so the last thing I want to do is check this condition 3, right? Def, I'm just going to call it foo-foo. I don't know, foo bar car. I don't know. 3, equation 3, right? Okay, so this is going to accept an X, and I want to check this an X and a Y, which is going to be a string and a string, and this is going to return a bool. Right? And I want to check the condition on page 14. Check the condition 3 on page 14, and I'm not going to put in a doc type. So I have 2 propositions here. So the first proposition needs to check that X is greater than Y. Right? So I have P, so this is where things are going to get a little bit hairy. Right? I have a lambda function which takes X to a lambda function which takes Y to X is less than Y. Right? So I can show you. Right? So I have P, which is a function. I have P of 2, which is I have P of A, which is a function, and then I can also have P of A of B. What is happening? Oh, sorry. Right. It is the case that B is less than A. Okay, so in any case, I can say this, and then I can say return for all, so what am I checking? For all X and X, there is Y. So for all PX, for all, okay, I have to cheat because this is complicated. I don't want to screw it up. It is, okay, this. For all X, there is Y PX, right? So I regret showing you this. You don't have to understand it. Study it in the lab if you want. I'd have to draw a lot of diagrams. I think this is overambitious. Okay, so ignore this. That maybe was too much, but this is fine, right? And this is fine. You should understand that a function could take another function. So tomorrow, regular schedule. Friday, optional. Yeah, but neural networks on Friday. Yeah. Sons of bitch. Stop! Stop!